All right, so this will be the third and final session about our ML app. So in the last session, we discussed about how to connect to Microsoft SQL Server and get our data from the table, right? So I think we had this kind of a table weather test data, and we uh, took this as an input, and we tried to see if our API was able to fetch from the SQL Server or not. From there, we'll continue. I have made some more changes and I have modified the complete code. So this will be more likely a code walkthrough. Of course, you can get this code in GitHub, wherein you can just download and run for yourself and see if it works at your environment or not. So let's start with train. Uh, so the first thing is that in train, this train is getting imported from model.train. So I'll just go to that folder and show you what the code is. So previously we had some code to read from the table here itself, but then I modified it a little further. So the modification was all the inputs will come from configs, right? So we in the config we have connections, we have input, and we have something called as config.py. And something to do with the inputs, we have some more functions which can help us read from this configs and convert that to a data frame. So that happens in operations.py. Okay, so let's go to this get data. Now, if you notice, the get data is getting imported from utils.operations. I'll go to that file. You can simply click on control and then click. It'll take you that particular function. So in operations, which is there in my utils file, you have some get data. Based on the input, whether it is from a DB or if it is from a CSV file, I'm going to read the data set. Okay, so let's imagine that my input says the source is DB, then this will be my input. Of course, the same thing happens for test. So if it is not trained data, then I'll go with my else condition. I'll look at the test data query and read that. Similarly, the same thing happens for my CSV file. Okay. After loading the data and putting it in our memory in data frame, we will then go to the pre-process, which is also in utils under operations file. In pre-process, what you're doing is the moment you load the data, you're going to rename the columns. Of course, the rename columns actually happens in the previous thing itself. When I get the data, I'm calling this column mapper. In column mapper, it's renaming all the columns. Of course, we should not do this hard coding, but just in case for this particular data set, I didn't want to waste a lot of time in this aesthetics and all, so I just hard coded them. And then in pre-process, we say what all things that we want to do. So the first thing is like impute nulls. I think the brief about this function is explained in logistic regression, so I don't want to repeat that. Only change that we're trying to do is like, if it is train, I'm going to save it in my outputs. Let us say this will be my pickle file, and if it is test, I'm going to read this pickle file like this and impute from that particular train data set and impute the null values into my test so that the test null values can be replaced. Okay, this is about the pre-process class, wherein I have something like impute nulls, which is dealing with both categorical and container features. We also have something called as pipeline. It's the same pipeline that we had in logistic regression, but I made this as a part of my pre-process class, and this will also do the same thing, like both categorical and numerical features it will do. Okay, so let's go back to train. You get the pre-process class, and once you pre-process, the pre-process class is then sent to xtrain and ytrain splits, followed by the pipe fit underscore transform, and followed by the model suite. Say if you want to see what the model suite is. So this is part of my model. Under model, I have one more file called model.py. In this, you can have multiple functions. Say, for example, I had function for logistic regression. Imagine this model suite to be something like you have various number of models. and you want to try and test each of the model, and whichever model is having the lowest accuracy, you can use that for prediction. Say I made this for logistic regression, you can also have for decision trees, maybe KNN and any other model that you want to try, maybe SVM and so on. Like we did not cover those models yet, but just in case if I'll go to that point, we can have one function each for each of those models and try and predict with each of those and see which one is having the lowest error. Okay, so the model suite will be used for storing all the models. Of course, it also has a evaluate method to tell you which what is a error metric for that particular model which you trained for. Once the training is over, you'll save the model. You'll look at the evaluation. You'll save the model by using joblib. Okay, so you can think like for decision trees, you'll have one more couple of codes. For maybe random forest, you'll have a couple of codes like that. You know? Then it'll tell that the model is saved in the outputs. So train does two things. One, it is saving the model, and second, it is also storing some artifacts that is required for uh, pre-processing your train. Say, for example, I have a pipeline. It has to be fit on the train data and then uh, uh, transform on the test data. So for transformation purpose, you have to save that pipeline after the fit is done. Okay. This is about train. Let us imagine that you have completed train. Now the third API which we are going to speak about is predict. What will predict do is it will first pre-process the test data, like all the null values it will try to replace. So it will go to make predictions. Again, it is part of my train, train.py. In make predictions, it is going to call the same function, get data, but the train data will be false. The keyword argument will be false, followed by pre-process. In this pre-process, it is going to tell you, say, for example, if my input from train is true, then you can notice that it will execute this part of the code, and your test data will get uh, uh, imputed for all the null values and all. Of course, we in this data set we did not do the outlier replacing or the capping of outliers. You can also do that. You can have one more function under this pre-process for capping the outliers and seeing if the data is uniform or not. Okay, you can add more features to that particular class. Once the pre-process over, then you go and do the transformation. And once the transformation over, you can load back the same model which you trained in the train. Okay. Previously, we are trying to save it into a pickle file. Here, we are trying to load that model into a pickle file, and then we are going to predict, and then we are going to store it in some CSV file. Of course, if you want to store it in some kind of a database, you can do that also. For simplicity, I just wanted to show I wanted to export it to a CSV file so that we can have a look at what the predictions were. So that is it. So I'll just show you one thing. Let me go and show you the config also. I did not show you the config. So in config, we have two classes for validating the payloads. In connections, you already saw we have the PyODBC connector for connecting to SQL Server. And inputs, we have an extra query for a test data set. This is the weather_test, which I uploaded into my local DB. Okay. Data is one folder where you want to load the data from. So just in case if the data is not coming from the DB, this will be a small CSV file, but actually it is not preferable. Honestly, if you ask me, then it should come from maybe an S3 bucket or any other cloud storage. This .csv file should not be present in your Git. Of course, we will also try to upload the code to Git so that you can download it from that repo. So just for your knowledge, I'm saying that. Okay. And the operations.py, I told you, it is all to do with pre-processing. Anything to do with pre-processing, it's all sitting here. Getting the data, pre-processing the data, handling the null values, storing them for using for replacing with the test data. All that is done in operations. I think that's all. That's all changes that I have made. You can definitely download the code and see for yourself. What I'll do now is I'll open my Postman. I'll go to my train. So let us see if all the functionality works or not. So first thing I'll do is I'll say don't train, just store the data. So I'm going to read from DB. When I read from DB, this particular path makes no sense. So let me just go and hit it. Okay, the code is not running. My bad. So dot app scripts activate fast API dev main.py. Okay. Whenever I run this code, I always feel like I'm watching a Matrix movie. So let's go and hit it. This will be my train. I'm saying that don't train the model, just do the pre-processing and save the model, save the dataset. Okay, it's going to run. It's reading from the database and it is doing the pre-processing. And finally, you see that there are no null values present in my data. And it's stored in the outputs. Okay, now you can see in the outputs, I see something called as data.pickle. Now let us do the same activity without DB. I'll just delete this one more time. Let me just delete it from here. Data.pickle. Okay, I deleted that. I don't see the output folders. I don't see anything in the output folder. I'll go back to my API. Instead of DB, I'll say CSV file. And it should take from this file path, the weather training data.csv. Okay, so let us do the same thing and see what happens. Now it's running again, doing the same activity, and it's stored. Now you see the data.pickle. So the train part is working fine. Okay, even if you do it with DB or with the CSV file, it is doing fine. Now the thing is that we want to train it. So let me go and change this value to true so that I can get couple of more values. I should get the pipeline pickle as well as the logistic regression pickle. Okay. So when I go and hit send, let us see one more time. And then it's gonna do the same operation again. It is reading from the same activity from the DB. And it stored the logistic regression, the model also, as well as a pipeline. Now, when we go and try to predict, imagine this like this. Okay, so you made some training on a development environment. You saved those models in some kind of a zip or artifact and deployed this in maybe production or a user acceptance environment where you do not have access. Now the model is not going to get trained there again. Let us say, okay, the model is not getting trained there, but in fact, this whatever pickle file that you find here, this will be used for prediction purpose. And then you see how the model is predicting on an unseen data in the user acceptance environment. Okay, now I'll just go to train. Oh, sorry, predict. And if I want to predict, I'll make it as true. And I want to say the model path is present in this particular folder, this particular path. Why I'm specifying the model path is because, let us say, if you have some more models like random forest and decision trees, which are performing much better, so you can give which path you want to use for prediction purpose. In this case, I have only logistic regression, so I'm sending that. So you can create couple of more models and use them for prediction purpose. So now the source will be from the database. I'm going to predict, and the model will be logistic regression. Okay, let's go and hit send. You can see now it's doing the pre-processing part, and it is done. Okay. Uh, then you can see the predictions.csv, a new file got created, which actually has our predictions. So in train.py, when you go to this make predictions, I see that whenever I have to predict it, I'm going to use the existing model, and from the existing model, I'm going to make the prediction, and I'm going to store it in CSV file. So this is what the complete walkthrough of machine learning app would be. I do not have the data ready. I mean, I did not deploy it to the cloud yet, but in future when I have access to AWS or Azure, I will definitely show you how we can deploy this in cloud and how we can use this trained model in the cloud to make predictions from a S3 bucket or a Cloud storage. Now that both the APIs are over, the train and the predict, we are left with pushing our code to Git, and for that we will have to just add git add and followed by all the file names, say for example main.py, requirements.txt, followed by your config file, then config. Under config we have inputs as well as connections. So have inputs, config, connections, and then we have data. Let me add models. In model you have train, and in model you have one more model.py. Outputs you don't have to add it, and in utils we have something called as operations, and then get commit sm, say initial push. I have already done this, so it might not push my code. I have already pushed it to my origin. Say f origin master. Let's see. So you'll find all my code, and yeah, it's already up to date. You'll find my code in my URL here. Say if I go to Sanjeev Kalepalli, and you'll find under my repos. Sorry, find it here. Yeah, you'll find it under ML app repositories. So when you go to ML app, you'll find all the necessary code. Okay, I think you can. All you have to do is just under code, copy this URL and do a git clone, and then it will fetch the code into your local environment, wherein you can simply download and run it. Okay. I would like to thank to all those people who have come to this far to watch the third video. It really means a lot to me, and thank you so much for watching my video.